call me clean sheets. Life na school, I need to teach lesson. I'm not a fool, just a common person. God's time, no be restore work clock. Sometimes, even word best, no they go word call.
Welcome back to my class. My name is Carlos. In today's class, we are looking at what we call moment and equilibrium in physics. Here is the question we are asked to break down. Now, I want to start this. What is moment? Moment is the force times what? Perpendicular what? Distance. So for every moment, there must also exist what they call equilibrium in most cases. So let's see how to resolve these questions with ease, owing to the fact that moment is a vector quantity, and moment is the product of a force times what? A perpendicular what? Distance, hence has a direction. Let's try this question. We are told that a uniform rod 1 meter, this term means 100 centimeter. Whenever you hear the word 1 meter, is 100 what? Centimeter. A uniform rod 1 meter long of mass 5 grams is supported horizontally on two knife edges placed 10 centimeter from each end. What will be the reaction at this support when 100-gram mass is suspended 10 centimeter from the midpoint of the rod? Now, I want to describe this particular statement into diagrams. First of all, what I want you to know is this: for moment about the force, what we require to know is what we call force and distance. So in this case, 1 meter, understand this, that 1 meter is the same as what? 100 what? Centimeter. Whenever you see a meter rod. Also note that if you have in kilogram, you times by 10. If you have in kilogram to Newton is what? Times 10 to get Newton. Kilogram to Newton, what do? You multiply by 10. But in this case, we have 50 grams. So 50 grams is equal to 50 over 100 to kilogram. And we'll now be having over 1,000 kilogram. We'll now be having 0.05 watt kg. Also, we have 100 grams. Also, where is it? 100 grams. 100 grams to kilogram will now be what? 100 over 1,000, which is equal to what? 0.1 kilogram. But what we need is what? Newton. So what do we do here? A particular what times 10 to Newton. We're going to times this by 10. But before we do that, let's draw the diagram of this stuff. This is the diagram, for example. A meter rod of this nature. We are told that it's 100 centimeters. The whole distance from here to here is 100 centimeters because the meter rod 100 cm, 100 centimeters. Okay, and we are told that it has a mass, as to say, the center of gravity, the mass of the rod at the middle here is what? Let's assume is there. The middle is 50 grams, and 50 grams is now what? 0.5 Newton. Multiply this times 10. Going to get that. All right, let's go. As in force, 50 grams is that. All right. Now the next thing we are doing right now is to follow the statement. I said is supported horizontally on two knife edges. And this knife edge is 10 centimeters from what? Each end. Is the ends of it. So from here, let's say from here to here is 10. Is a knife edge. Is a knife edge. So here is 10 centimeter. Here is 10 centimeters. So here we want 40. Here we want 40 because it's what? 50, 50. Let's go now. What the next statement here? We are told that what will be the reaction at this support when 100-gram mass is suspended 10 centimeters from the midpoint. Anywhere I can use is the midpoint. Anywhere I can use, they are told that it has from here to here 10 centimeters. You see, 10 cm, and the mass is what? 100 grams, which equals to what? 1 Newton. 1 Newton. Okay, let's go. So it means that here is now what? 30 centimeter. Here remains 40 centimeter because it's 50, 50. Now, this part is called the knife edge support. The knife edge support. So let's call this place force P and force Q. That is support of the knife edge or the fulcrum. We call this one the fulcrum, the knife edge, or what? The pivot. Let's go. Now, what the next thing to do right now? Let's now solve this question. How do we solve this question? Very simple. Very simple. So the idea is now this: there are two laws that govern this system. The first law is this: that total upward force is equal to total downward force. You must know that first law. The first law is that total upward force equals to what? Total downward force. And the other law is called the law of what? Moment. Principle of moment, which is now what? total anti-clockwise moment is equal to what? Total clockwise moment. So let's not solve. Let's take moments about a particular point P, about this point P, this force. I call this point here, I call it point M, and I call this point N. Let's take moments about this point M. Let's see. All the whole force will go to M, this point here. This force is going to M2, this force here. This force here is coming to M2, the total distance and the likes. So this point M, it means that this force here is what neutralized. It's useless because all the forces are going to this point M here. This one to the point. Then let's see. Let's compare the first law. The first law says that upward force is equal to what? Downward force. Let's see. It means that this force plus this force, P plus Q, is equal to what? This plus this, which is now what? 0.5 or 1 plus 0.5. It means that this is the first law. P plus Q is now equal to what? 1.5. First equation that you must know. Now the next one is what? Clockwise moment equal to what? Anti-clockwise moment. So let's look at this one now. So this one and this one and this one. Let's see. I have to forget this thing. This is the clock. This is the clock and it moves like this. I have this. So it moves like this. It moves like this. Is the clock. It moves like this. So here is called clockwise moment. Here's clockwise. Here's also what? Clockwise. And here's what? Anti-clockwise. So let's see. So we can now say that for the first one, this one, the force here, 1 times 30 perpendicular distance from here to here. 1 times 30 is the first. So we can say clockwise moment is equal to what? Anti-clockwise moment. Let's see, for clockwise moment, we have what? The first one is 1 into the force times distance, is now what? 1 times 30 plus second force 0.5. The total distance here is now what? 40. 10 plus 30 is what? 40. We now have 0.5 times what? 40 is equals to what? The anti-clockwise moment. We now have from here to the whole here is 80. Because here is 10, here is 10, so you have 80. From here to here be what? 80 centimeters. See that now? So now I have Q times 80. Q times what? 80. So let's now go down. So here will be what? 30 plus this is now what? 20. 20 is equals to what? 80Q. So it means that my Q will now be what? 80, rather 50 over 80. What do we now get? We want to get 0.625. 0.625 Newton. That's the first support, Q. Let's now come here to get the second support, what? P. We have P will now be what? 1.5 minus Q. So P is now equal to what? 1.5 minus what? 0.625, and my P will now be finally what? 0.875. 0.875 Newton. So this I will solve for the knife edge support we are asked to look for. So the knife edge support, the forces here is what? P and Q. P is what? 0.875 Newton, and Q is what? 0.65 Newton. Thank you for your time and God bless you. Please, if you love what you've just seen, kindly subscribe to this channel for more of this content. I'll be sending more questions to writing in the exam. I'll take this template to achieve better. Subscribe, like, and share, and God bless you. Bye bye.